Assalamualaikum and hi. Today, my Group 8, will present about muscle innervation and the role of calcium in muscle contraction. Our group member is me, Soy Nadira, Eunice Claire, Chen Ziqian, and Hazman Haris. Muscle is stimulated by motor nerve fiber, and the nerve fiber have several branches, and each of it and at axon terminal in close proximity to the sarcolemma of muscle fiber. There is a small gap, and we can see here is the small gap, and it's called synaptic cleft. And synaptic cleft separate the axon terminal from the sarcolemma. This entire region we call as neuromuscular junction. Neuromuscular junction is a chemical synapse between a motor neuron and a muscle fiber. How muscle contraction happen? First of all, in axon terminal that contains synaptic vesicle filled with the neurotransmitter acetylcholine, or we call as ACH. And the nerve impulse will travel into an axon terminal by travel down a motor neuron. And the synaptic vesicle will release ACH into the synaptic cleft. After that, in sarcolemma, ACH will diffuse and across the cleft and bind to receptor at sarcolemma. Sarcolemma will generate impulse that spread over the sarcolemma and down to T-tubule to the sarcoplasmic reticulum. In sarcoplasmic reticulum, it will release calcium and cause filament in the sarcomeres to slide past one another. The sarcomeres contraction will result in myofibril contraction and turn the result in the muscle fiber. Muscle contraction happens once a neurotransmitter released in a neuromuscular junction and has initiated a response, it will be removed from the junction.
Okay, so we will continue with the role of calcium in muscle contraction. What is the role of calcium in muscle contraction? So the calcium ion, Ca2+, they come from the sarcoplasmic reticulum. The ion is combined with the troponin, which you can see in the diagram, and then when they combine, they expose the myosin body sheath. So this myosin body sheath is when you want to contract the muscle. So this is the cycle of the contraction of myosin. So this is myosin. For the first step is the ADP is hydrolyzed. So when ADP has hydrolyzed, they release ADP and P. You see this on the picture, ADP and P. They are hydrolyzed when the head of the myosin is attached. In the second step, the ADP and the P are bound to the myosin as myosin head attached to the actin. So you can see the myosin head is actually the attached and the magnetic, and then in the step, upon the ADP and P release, so when they release, the power stroke occurs. So when they are released, you know they push to this direction in the arrow and they leave, and then when the other ATP attached to the myosin head, so they revert back to their original position. So and then the cycle will continue. So contraction continue until nerve impulses and calcium ion return to their original site. So calcium ion pump back to calcium storage site by active transport protein that located at the membrane of sarcoplasmic reticulum. So this means that the contraction will continue until nerve impulses, and after and when they need to cease, the calcium ion will return to their original site by using active transport.
Usually it will happen during gym session when we lift heavy weights. During half squat, muscle spasm usually will happen on the lower back if we didn't do it correctly. Usually how it feels painful, and then we won't be able to move. You have to be static, only that position. It will be worse in the morning. The next day in the morning, when you wake up in the morning, it's really painful that you can't move. You need to move bit by bit, very slowly, to warm the muscle up, and then you'll be able to walk or like to bend your back. Cramp is the usual one. If we overtrain or dehydrated, then it usually happen on the calf. Usually the mild one would last like 2 or 3 days. because it's like just a moment that you just do it wrongly or wrong angle, then it will just come, in a blink of an eye. So usually if not so serious, it will last 2 to 3 days. Then just rest. If you get the chance to go for physiotherapy, we will apply some hot packs to make the muscle relax. But if it is serious, we will go and seek for advice from doctor. Usually they will give us medicine that for muscle relaxation, because muscle spasm usually happen when we overtrain and it's very tight. Of course, if we train every day, cooling down after the training means we stretch a lot to release the tension in the muscle. Definitely helps releasing the muscle tension. And then rest, recovery, and then all the recovery, extra recovery like ice bath, hot bath after the training would be helpful. So nutrition wise, we have a lot of supplements for recovery. That one we need to seek help from our nutritionist. Yeah, like I said, before it happens, make sure that you go for routine massage twice every week. We have to go because we train every day, and it's so high intensity training that our muscle is so tense. Other than the usual stretching after every session of training, we need to go for massage to relax the muscle. So if we didn't have the time to do it, or we overtrain but all the recovery things we didn't do well, then it really will lead to muscle spasm. But the prevention would be to go for massage and all the hot bath, cold bath, and then stretch a lot, then probably sleep well. And then maybe drink a lot of water to prevent have dehydration.
Before we end this session, time for a recap. Muscles contraction is stimulated by motor nerve fibers. Axon terminals contain synaptic vesicles filled with the neurotransmitter acetylcholine ACH. When nerve impulses traveling down a motor neuron arrive at an axon terminal, the synaptic vesicles release ACH into the synaptic cleft. ACH quickly diffuses across the cleft and binds to receptors in the sarcolemma. Sarcolemma generates impulses that spread over the sarcolemma and down T-tubules to the sarcoplasmic reticulum. The release of calcium from the sarcoplasmic reticulum causes the filaments and sarcomeres to slide past one another. Sarcomer contraction results in myofibril contraction, which in turn results in muscle fiber and finally muscle contraction.
Now, for role of calcium in muscle contraction. First, ADP is hydrolyzed when the myosin head is unattached. Second, ADP plus P are bound to myosin as the myosin head attaches to actin. Upon ADP plus P release, power stroke occurs. Head bends and pulls the actin. Last, binding of ADP causes myosin heads to assume the resting position. That's all from Group 8. Thank you.